Alright, now let's go to disaccharides. So we have the two disaccharides or the two monosaccharides are linked together by acetal formation to form disaccharides. Okay, so if we have here, alright. So one monosaccharide acts as our hemiacetal. Now this one, okay, what monosaccharide is this? Okay, we have glucose. Alright, glucose. Okay, so this one are glucose. This is our glucose. And then this is one monosaccharide. So one acts as a hemiacetal. Okay, hemiacetal. We talked that hemiacetal is alright. If we have this C1, okay, so this is a hemiacetal. Okay, so remember hemiacetal, we have C, and then we have the OH, and then we have the R, and we have the OR, and then we have also an H. Okay. Diba kani kaya naman ni siya? Mo basta hemiacetal ni siya kas kay diba kani ang H. Mao ni siya. Mao ni kaning OR. Okay, suppose kani. Mao ni siyang OR. Dayon kini. This is an OR also. This is an R. Mao ni siya. And then the OH is this one. Right? Follow. Okay, I hope you can follow. Mao na siya. This is a hemiacetal. Because hemiacetal is C, the O, H, R, O, R, and then we have another H. This one is H. Diba mo ba na ito hemiacetal? Okay, now, okay, so it says that this is a hemiacetal. One acts as a hemiacetal, okay, this one, and the other acts as an alcohol. So this is our alcohol. Alcohol has R, O, H. Okay, the OH here is mo ni siya. And then the OR, this one, the whole OR. Okay, the whole R rather. Okay, mo na siya. So this is an alcohol. This one is acetal, hemiacetal. This one acts as an alcohol. And then they form, okay, during condensation of the hydroxyl function of the hemiacetal group of one of monosaccharides with the hydroxyl group of another monosaccharides. Okay, during condensation and class, condensation of hemiacetal, condensation of an alcohol, then, okay, so you see this one, okay, the HO and H here, the OH in the alcohol, and the H in a hemiacetal, okay, will bond together forming H2O, and the oxygen here in our hemiacetal here will form our glycoside. Okay, so this one is our glycoside. And the bond here, okay, the linkage, we call the linkage as glycosidic linkage. Glycoside, one glycoside forming, okay, so that one is glycosidic linkage. Glycoside. So the bond here, this one is our glycosidic bond, joining the two saccharide units. Yes, one saccharide, two saccharide. So this one is our disaccharide. Disaccharide is a formation of two saccharides. Okay, all right. Now let's go. So example, we have here the maltose, or our reducing sugar. So malt sugar found in corn syrup, it's malt. Okay. Then and germinating seeds, so it's malt. It's the sugar we find there. Okay, malt consists of two glucose. Okay, so a maltose is consist of two glucose. We have one glucose and one glucose. Okay, the anomeric carbon in the OH or the acetal, hemiacetal, uh, reacts to our alcohol. This one, this alcohol in carbon 4. Okay, and then it forms a glycosidic linkage. So we call the linkage as alpha because it's below, class below. Then that's alpha and then beta if ano yung linkage. Nasa babaw ang linkage ha. Okay, so we have alpha, and then we write the low cut, the position. We have carbon 1, so alpha, and then parenthesis 1, and then 4, because it's in carbon 4. 4. So that is the linkage. Alpha 1 4 linkage or glycosidic linkage. We have here. So in a maltose is joined by an alpha 1 4 glycosidic linkage. It is consists of two glucose, one glucose, two glucose. And then also class, we have alpha 1 4 glycosidic bond means that the first sugar is an alpha configuration. Okay, so it explains here. An alpha sugar. Yes, this is an alpha sugar class. Okay, alpha sugar. Alpha glucose muna siya. Alpha glucose. And then, yes, that's the C1. And it is linked to C4. This one, the C4 of the second sugar component. The second sugar may be either alpha or beta anomer. So this one, the second sugar could be alpha or beta anomer. Di na siya kinahanglanon sa name. Ang kinahanglanon na to nga mag-base ta sa name is on the first sugar. On the first sugar, we identify that it is alpha or beta. Disregard the anomeric carbon in our second sugar. Kaya masunod is the first sugar. Okay? And then also, no, but if you are only given with this one, a disaccharide, then nakabalo kung ma-identify if it's an alpha or beta. The only, determining point is that the linkage, as you can see, the linkage is pa-down. Okay, that's beta, and if pa-up, this one is alpha, this one is beta. Okay. So maltose, that is formed by glucose and then we add another glucose. What about cellular bias? Cellular bias is one of the major fragments isolated after extensive hydrolysis of cellulose. Okay, so you have cellular bias came from our cellulose. So we have here one. Okay, so we have a glucose and then a glucose also class. So a glucose, and then the only difference is the linkage. As you can see, the linkage class here, that is our beta. Okay, this is a beta 1 4 glycosidic linkage. So this is our cellular bias. So the only difference to our maltose is the linkage. Okay, Yeah, so this is beta 1 for linkage or beta 1 for glycosidic linkage. Okay, you put the name glycosidic linkage. It is consists of two glucose units. Glucose and then glucose. Now, what is maltose is digested easily by humans because we have enzymes that can break alpha. Okay, one for linkages but not beta linkages. So in our body, maltose is more preferable because it is that the bond there is alpha 1 4. Alpha 1 to 4 linkage, glycosidic linkage, whereas for our cellular bias it's beta. And then our body has an enzyme that can catalyze alpha 1 for linkage than beta 1 for linkage. So one alpha maltose is more preferable than our cellular bias. Mostly cellular bias we can find them in animal cells. No. So okay. Plants. Sorry. Okay. Then we have lactose. Again, it is a reducing sugar. Okay, it is a milk sugar, and in human it is 7% to 8% lactose, while for cow's milk it is 4% to 5% lactose. Okay, so milk sugar in human it's 7% to 8%. So mas daghan siya lactose sa human whereas to kaysa cow's milk. Okay. And then we have, oh, I see that's why class for animals, ano siya no? The milk for people is not the same for milk of the animals. That's why differentiate sila nga. Sometimes ang mga animals ug drink sila sa beer brand is magkalibanga sila. Because of this one, the cow's milk even a cow's milk has only 4% to 5% lactose. And whereas for the human, mas daghan siya og lactose. And then the lactase, okay, for example, what about the dog ka, no? But sige, kanin for the cow, if mainom po sila ani sa human's milk, then ano po sila kalibangaon sila because the lactase, the enzyme nga mo break sa lactose to convert it into glucose or to monosaccharides to is gamay ra. Nya mas daghan ang iyahang mas daghan ang lactose nga naa sa milk. So mo siya kalibangaon na din siya. Kay gamay ra ang kaniyang lactase. Okay. Then we have mo din ang kalibangaon na sila kanang kanding. Ug kaniya tong dogs. Okay, we have consist of beta galactose with uh linkage of beta 1,4 glycosidic linkage to beta glucose or an alpha glucose. Okay, either way man siya kay this one. Oh. Okay, unsa either way nako. Ano ko either way is kanya to sugar ay kanya tong alcohol. This one acts as our hemiacetal, this one acts our alcohol. Now either which if it is beta or alpha. Kaya ang mag-matter siya, there is to ang first sugar. Now, in this case, what is the linkage to our lactose? As you can see, it is up. So, it is up. This is a beta. Beta 1, 4. 1 came from hemiacetal carbon here. And then the 4 comes from our alcohol. Okay, carbon from our alcohol. So, beta one for glycosidic linkage, and then we have a glucose, and then we have a we have a galactose, and then we have a glucose. So lactose is a combination of our galactose and our glucose. Okay, so lactose intolerance, we have, okay, so this one. So lactose intolerance, it is a condition in which people lack the enzyme, okay, lactase, needed to hydrolyze, okay, the lactose to galactose, and we have the glucose. Alright, class, so this one is lactose intolerance. Okay, so lactose intolerance, it's very common to people. And then, karon na ako nabawaan na common pa siya sa ato ang ay nahibawan na pero common siya sa animals. That's why they are not milk for animals and milk for people. They are not compatible. So, ang body nila dili makakuan siya, mag-adjust, maglisod og adjust because this one we have here for people, we have lactose intolerance. When a baby has lactase, okay, when a baby has ano siya, no enzyme lactase, and inipainom mo siya og milk is ano siya, magkalibanga siya, either magsuka o magkalibanga because the baby has no or he or she lacks enzyme lactase that will convert or hydrolyze lactose into galactose or glucose. Mao na siya ang mga wala di sila ka-tolerate og mga lactose. Same thing to dogs also na magkalibanga po sila because they don't have they have an enzyme lactase. However, because for example, we have the cow's milk. The cow's milk is lower ang iyang lactose, lower iyang lactose component sa sugar, and then so lower po iyang lactase ani. And then if painom mo na to siya og milk, human milk, then di siya ka-tolerate because human milk has more lactose than the animal's milk. Animal's milk. Yeah. Okay, so maong magkalibang dahil sila. And then we have lactose intolerance. It is unpleasant, but its effects can be avoided by diet that rigorously excluded milk and milk products. Okay, so if you have lactose intolerance, then this can be avoided by not drinking milk, or you can but those milks na lactose free and it's kind of mahal po siya. Okay, lactose free. And then we have, okay, so ginaiwasan po ang mga foods, dairy or milk products. So that is lactose intolerance. It is a condition in which people lack the enzyme lactase. So lactase is the enzyme that will break, okay, that will break this one because it's a disaccharide man. So yan ay break into monosaccharide because the monosaccharide is kan mao man ang gamiton sa ato ang body. Okay. Now we have this one. Okay, so this formation, okay, this is our beta lactose. Okay, beta. Beta D lactose. Okay, beta. So the linkage is beta 1 for glycosidic linkage. Okay, then we have lactose intolerance versus galactosemia. Okay, we have talked this, then galactosemia, lactose intolerance is when undigested lactose attracts water causing fullness, discomfort, cramping, nausea, and diarrhea. Okay, so the undigested because we lack lactase, so the undigested lactose will attract to the water in our body, and then it will cause us discomfort in our stomach. vomiting, nausea, diarrhea, and then bacterial and fermentation of lactose along the intestinal tract produces acid, lactic acid, and gas, adding the discomfort. Yes, because our body we have HCl. Okay, we have HCl that's very acidic. Wait. Okay. Okay, and the reaction of our lactose with our HCl, so mahimo siyang acidic, forming lactic acid, and this lactic acid produces gas. Okay, and adding to the discomfort sa ano siya, hyperacidity, mag-add na dun siya hyperacidity. So, that's why hyperacidic people used to avoid milk because milk can be acidic during the reaction of our body. It has lactic acid. Okay, now whereas for galactosemia, the genetic disease caused by the absence of enzymes needed for the conversion of galactose. Okay, again, we note that everything, monosaccharide, all sugars will be converted to simple sugar, glucose. And then, even if galactose is already simple, our body needs to convert it to glucose pa jud. And if we lack that enzyme called galactase, okay, so take note of that. In lactose, the enzyme is lactase. In galactose, the enzyme to break that one is galactase. And then the disease would be galactosemia. Okay, so a reduced form of galactose called dulcitol or galactitol, a toxic metabolite is produced and accumulates. So, mo na siya. And if galactosemia is not treated, it leads to severe mental retardation, cataracts, and early death. So, it has ano pa siya, no? Mas severe yung result kaysa sa lactose intolerance can be avoided, but this one is you have to really avoid this one kay if not treated, and even you have to treat this one, it leads to severe mental retardation, cataracts, and early deaths. Okay, so this is reasonable because galactose, the in our blood, the antigens there, it has galactose. So that's it. Okay. Nakalink siya sa ato ang blood, whereas the lactose, it links only to the milk. Yeah, pwede siya immune, pwede dili. The galactose is part of our body, part of our blood na siya. Okay. And then if without galactase, so the galactose, okay, will be reduced into galactitol. Okay. So here, the undigested lactose, will just attract water, causing discomfort na saya and diarrhea. Here, the undigested galactose or the unconverted or reduced galactose will uh is very toxic. It's very toxic, uh, and it is produced and accumulates. So galactitol is toxic. The galactose, the undigested galactose is toxic. So when toxic, if nourished sa imong body, then it will lead you to this retardation and this cataracts and deaths. Oh, hadlok di siya gamay. Mas hadlok siya kaysa sa lactose intolerance. Okay, so now let's go. Okay, so that's it for lactose and galactose. Okay, so again, the galactose is The lactose is alpha is beta 1 for glycosidic linkage. Okay, now let's go to okay, galactose is not a disaccharide class, huh? Okay, and then we have this one, disaccharides. So we have sucrose. It is non-reducing sugar. Then the common table sugar and okay, so this one, our table sugar, monotone brown sugar and white sugar, they are sucrose. The common, that's why this one is C12O, pila ni class? 14, O12, diba? C6 times O is equal to 6 plus 2N, diba? 2. So, 14. C12, O, 4, C12, H14, O12. So we have the common table sugar are the most abundant of all disaccharides found in plants, and it is produced commercially from juice of sugarcane and sugar beets. So the alpha anomeric carbon of glucose. Okay, so the alpha anomeric carbon, so this one, the linkage will be alpha. Joins the beta anomeric carbon fructose. So alpha 1, and then the linkage for this is fructose. Okay, now let's take a look on what carbon in a pentose that that links or that bonds to our hexose. Okay, so let's take a look on this one first. In hexose to hexose, it's 1,4. 1,4 yung bind. But this is a pentose. In a pentose, it's carbon 2. Okay, so the anomeric carbon 2 in fructose. Okay, so we have both anomeric carbon. And we have here our glucose. This is our glucose and this is our sucrose. Oh no, this is our fructose. Okay. So this one is our fructose, this one is our glucose. Now, we know that in a fructose, the anomeric carbon, the carbon where in the hemiketal form, is in C2. Okay, so we have this one, it's C2. Wait. This one is C2. And this C2, okay. So the glucose in C1, the hemiacetal, then this will act as our alcohol. Okay, the OH in our fructose and the H in our glucose will form a water, H2O, and then the O in our glucose will create a bind to our fructose in C1 and C2 particularly. So this is carbon 2, diba? Carbon 2 because this is carbon 1. Carbon 1 does not participate in the cyclic formation of our fructose. So we have carbon 2 and then we have carbon 1. Carbon 1 and carbon 2 links together forming alpha. Okay, alpha for our glucose. We have alpha. And then the OH in fructose, since this is above, so we have beta. Okay, alpha, beta, 1. 1, it's in carbon 1, and in fructose is in carbon 2. 1 to 2, alpha, beta, 1 to 2 linkage. You see this one, class? Okay, please read na your handout if it's no gamay kay siya. So alpha beta 1 2 linkage. This forms as our sucrose. Take note of the linkage. It's alpha beta 1 2. The alpha came from our glucose, the hemiacetal, and the beta came from our fructose, our alcohol. The one here came from our anomeric carbon in glucose, whereas the two came from anomeric carbon fructose. Okay, you see, class, it's a big difference for sucrose and for other disaccharides like lactose. Lactose is formed from galactose and glucose, and then we have the the linkage is 1,4. Okay, 1,4. Only one anomeric carbon, one OH in an anomeric carbon participates, while in our fructose, two anomeric carbon. In our sucrose rather, two anomeric carbons. We have anomeric carbon in glucose and then anomeric carbon in our fructose. Okay, so that's it. So take note of the linkage. And then we have the alpha. Okay, so this one is alpha 1 to glycosidic bind. So the bind is, no, both anomeric siya. Okay, let's take a look at this one. This one, okay, you see this one? It's our water and then the O here. This one. So this one is the linkage is alpha beta 1 2. Okay, we have disaccharides, invert sugars. It's optical activities. Okay, we have sucrose. Okay, so what does invert sugar means? Wait a minute. The term invert sugar comes from the observation that the direction of rotation of plane polarized light. So we have changes from positive or clockwise to negative, which is counterclockwise when sucrose is hydrolyzed to invert sugar. So the rotation is 66 degrees, which is positive, it means clockwise. And then the rotation for glucose is positive 53 degrees, so clockwise again. Fructose is negative. And then we have invert sugar, which is negative. So the D-glucose and the D-fructose are invert sugars. And the net rotation for the invert sugar mixture of fructose is negative 92 degrees, and for glucose is 552 degrees. And then we have the net would be if the glucose is positive 53 plus negative 92, that would be 42, so 39. That would be negative 39 degrees. So that's the our invert sugar is negative 39 na that. And then we have invert sugar has much greater tendency to remain in solution. So we have the honeybees and other insects possess an enzyme called invertase, okay, that hydrolyzes sucrose to invert sugar. Okay, so we have sucrose and then using an enzyme, then it will be converted to invert sugars, which are glucose and the D-fructose. So for honeybees, it is called invertase, but for human, it is called a sucrase. Sucrase is an enzyme that hydrolyzes sucrose. Lactase is an enzyme that hydrolyzes lactose, while cellulase is an enzyme that hydrolyzes cellulose. And then we also have maltase for maltose and galactase for galactose. Okay, so alright. Now, which of these disaccharides, maltose, cellular bias, lactose, and sucrose, have the following structural or reaction? Okay, so we have two different monosaccharide units are present. Okay, two different monosaccharides. So all disaccharides. So we have maltose, cellular bias, lactose, and sucrose. Letter B, hydrolysis produces only monosaccharides. Number one. It says two different monosaccharides. So for different, because a maltose has the same monosaccharide. It's glucose plus glucose. And then we have also a cellular bias is a glucose plus glucose. It depend on just on the alpha and beta enumeric link on the alpha and beta positioning. Then we have the hydrolysis, letter B, hydrolysis produces only monosaccharides. Of course, all disaccharides will be converted to monosaccharides. Letter C, its glycosidic linkage is a head-to-head linkage. Head-to-head, which means both an anomeric carbon. We have sucrose. Then letter D, it's not a reducing sugar. Okay, not a reducing sugar. Sucrose is the only non-reducing disaccharide. Okay. Alright, so that's the answer. Now let's go to artificial sweeteners. We have, okay, saccharin, aspartame, and sodium cyclamate. So artificial sweeteners, gamerged kayo, and then it's very sweet. It's artificial, unlike to our fructose. It's not artificial. It came from fruit. With these artificial sweeteners, remember natin mga magic sugars, gamay kaayo, and then mutamis to din ka siya. They are artificial sweeteners. Now, artificial sweeteners has disadvantages. Saccharin is, so we have this saccharin. It is the oldest of the artificial sweeteners, but its safety arose in 1977 from a study suggested that, okay, when you take a large dose of saccharin can cause, okay, bladder tumors in rats. So saccharin, its safety was diagnosed, and it has been proven that this large amount of saccharin can cause blood tumors for rats. That's so if it can cause that one to rats, rats in humans has rats in humans has pinakaduol og DNA type. Okay, so maybe this can cause also to harm to humans. So that's why the FDA has banned the saccharin. And then also we have sodium cyclamate. Okay, it was approved in FDA by 1949, and then later in 1969. Okay, one study or studies suggest that it can cause cancer in laboratory animals. Okay, so it can cause cancers to animals. And then we have, so that's why it was banned. Again, then we have also the aspartame. So aspartame or even NutraSweet. So we can see that one in our mga junk foods. We have NutraSweet. So when you read NutraSweet, it is an aspartame. So an aspartame is used because it tastes like sucrose. Our sugar, our table sugar sucrose, it tastes like sucrose, but it is 150 times sweeter than our sucrose. Okay, and also it provides 4 kilocalories per grams. 4 kilocalograms as the sucrose. But okay, so however, because this is aspartame and it's very sweet, so we only need gamay ra kayo nga dosage and then our food will taste so sweet. Okay. So this is ano siya, alluring. It sounds good for those who are in a diet because gamay ra kayong sugar nga makuha nimo. However, its safety lies with its hydrolysis products, the amino acids, aspartic acid, and the phenylalanine. Okay, so those during hydrolysis, we can have amino acids, and these amino acids are identical to those obtained from the digestions of proteins. The only danger poses is that it contains phenylalanine, an amino acid that can lead to mental retardation. So we have an aspartame. Aspartame sounds so good. However, during hydrolysis, we can form, we have this one an amino, and an amino can, we have, it contains phenylalanine. Okay, phenylalanine can lead to mental retardation. So it's not, it is not good. So there are children suffering from phenylketonuria or PKU. Okay, so they nakuha nila because of phenylalanine na ano na amino acid. Okay. And then we have our this one are another artificial sweetener which is sucralose. Okay, it looks like sucrose, however, the only difference is the chlorine. Okay. So this one is our sucralose. Sucralose. It is a derivative of sucrose. It came from derivative means it came from. Okay, it's a derivative from sucralose. Only difference is the Cl. The OH is the OH is replaced with chlorine. Okay, so we have an advantage of the sucralose to aspartame is that it is heat stable and therefore be used in cooked food. So this one we can use sucralose. And also take note sucralose is 600 times sweeter than our sucrose and has a similar taste. Okay, just like aspartame, it has a similar taste to sucrose. Aspartame is 150 times than sucrose, and then whereas sucralose is much sweeter, it's 600 times sweeter. Okay, and also, okay, it is calorie free because it cannot be hydrolyzed and is processed through the digestive tract. Okay, that's it. So far, and no, it has no disadvantage yet. The sucralose. But maybe in other books or other researches, we can find disadvantages on this sucralose because imagine it's 600 times sweeter than our sucrose. All right, so that's all for today. That's all for this video. In the next video, we will tackle about oligosaccharides. Okay, now let's tackle oligosaccharides. Okay, commonly found in onions, cabbage, broccoli, and wheat. In humans, intestinal bacterial action and the digestible raffinose and stichios present in beans produces gaseous products that can cause discomfort and flatulence. Okay, so we have this one. Our common oligosaccharide is what we call the raffinose, and we have stichios. Okay, this one. Alright, wait. Okay, so beta D fructose. Okay, So raffinose is very short na siya. Only three monosaccharides. We have alpha D galactose, alpha D glucose, and then we have our fructose. Okay, you see this one class? You see this one is our sucrose. A sucrose plus another galactose is our raffinose. And this one also is gal is our sucrose. Okay, this one is our sucrose, and then this one is galactose, and all the three is called raffinose. When you add that one with our galactose again, we can have our styrose. Oligosaccharide is ano siya? Is two when more than two monosaccharides are linked together, you can have oligosaccharides, but more than 2 to 10 only because more than 10 is different saccharide na. Okay, so we have araffinose is a derivative of sucrose, and and our styrose is a derivative of raffinose. Okay, so in our body, so when we have undigestible raffinose and styrose present in beans, so it can produce gaseous products that can cause discomfort and flatulence. Okay. Okay, then we also have solanine. A potato's toxin is an oligosaccharide found in association with alkaloid. Okay, solanine is something in our potato, di ba og green na ay green there ang part kay madaan na that is toxic na siya class that is called as solanine. It's a potato toxin. It's an oligosaccharide found in an association with our alkaloid. So its bitter taste of potatoes due to the relatively higher level of solanine. So it is bitter. And a potato, kaya na mag-green na siya, maubi ang nalain kay nagkaon nato because there's a presence of solanine and it's bitter. Okay, so it's an oligosaccharide. Now we have our oligosaccharide blood types and monosaccharides. Okay, so we've talked that our our antigens in our body, the sugar that participates in it could be our galactose. The galactose. Okay, this will be our antigens. If we have this type blood O, we have our galactose. The sugar there is galactose. But for type A, we can find acetylglucosamine. And then, oh, okay, wait. So if you are type A, then there is a presence of an acetylgalactosamine. So the antigen has an acetylgalactosamine if you are type A. So if not, then no an acetylgalactosamine. Okay. All right, now let's go. Okay, so that's all for this video. And next video, let's discuss polysaccharides.